Welcome back to TopTenz. I'm your host, Cosmic Horror Madman Eric Malachite, and today we're talking about homes, but specifically those not built by human beings. Today's script was written by Ed Hatchett, so if he's provided socials to us, they'll be right alongside links to my channel, Story Rant, and books. Let's get to it. The natural world is full of reminders of how inferior we are as a species. Not only do we lack or rely on technology to give us abilities that you might find attached to any given member of the X-Men, things like night vision, flight, or any meaningful level of strength, some of us also fail miserably at the most basic tasks, like feeding ourselves, raising our young, and disposing of waste. Most of us can't even build houses for ourselves, and those who build for us are incapable of doing so cleanly. So hang your economy-enslaved ecocide enabling head in shame as we run through 10 of the most stunning feats of architectural engineering from elsewhere in the animal kingdom. Starting with number 10, Bagworm Log Cabins. Unlike most butterflies and moths, which spin their cocoons out of silk, bagworm moth larvae make use of the resources around them, plant matter mostly. There are bagworm species all over the world, and many more styles of bag, the cocoon for which they are named, as well. Some are more interesting than others, like the feathery nests made of stork's bill seeds, but for the most part, they all hang like bags. More interesting are the miniature log or twig cabins that gracefully spiral to a tip. A study of 42 such structures in India built by the bagworm Clinia cremeri showed the design was anything but random. The larvae have a style in mind and look for the right sticks to build it, the various lengths required to assemble their spiraling tower. It takes them pretty much their whole lives to finish the job, but it's worth it. The males emerge as fuzzy black moths with transparent wings, while the females decay into a pile of eggs to spawn the next generation, which is very Lovecraftian. Number 9, Cattish Fly Submarines. Cattish flies, or sedge flies, are widely distributed around the world. They look like moths with hairy wings, but as larvae they live underwater. It's at this stage of life that caddis flies are at their most artful, spinning together their submarine cases with silk from their glands around their mouths, along with sandstones and plant matter. Depending on the species, these homes may be stationary or mobile. Styles are so characteristic of the species that builds them that while adult caddis flies are hard to tell apart, larvae can be identified by their cases. Some are smooth, some are lumpy, and so on. Only one larvae lives on land, in the leaf litter of the English West Midlands, Anoicula pusilla, the land caddis. All others inhabit submarines. Number 8, Ovenbird Abodes. Native to North America, the ovenbird gets its name from the resemblance of its adobe mud nest to a Dutch oven, at least if you squint really, really hard. Construction takes roughly 2 weeks, building the walls out from a bowl shape up, then back in at the top, while carefully avoiding collapse. By the end, the ovenbird will have worked 2,000 pellets, 10 pounds of mud into the sphere of its home. They also use plant matter and dung, nature's cement, for the structures and line it with grass for comfort. A circular side opening allows the family in and out while cleverly repelling attackers. Not only is the entrance offset from the branch, but it also has a curving wall inside 3/4 of the way to the roof, posing a severe obstacle for predators, in addition to the concrete-like adobe itself. There are actually 3 types of ovenbird nests, the other 2 being cavities and domes, but they're all enclosed, like little houses, unlike the vast majority of other bird homes. Cavity nests are typically established in woodpecker holes, natural cavities, or burrows up to 1 meter deep, which they may dig themselves, we're not sure. And dome nests are built with sticks, grass, feathers, and bone, with protection from thorns and barbed wire. Notably, they also use snakeskin. Number 7, bowerbird theme parks. Native to Australia and New Guinea, bowerbirds have the surprising distinction of being second only to humans in the adornment of their structures. In fact, their bowers, walls of sticks bent inwards to form arched shelters with cleared ground in front, have even drawn comparisons to Disney World. Just as the upper bricks of Sleeping Beauty's castle and the buildings of Main Street are smaller than at ground level, to make everything look taller, male bowerbirds used forced perspective to make their bowers look smaller, and themselves bigger according to one theory, to prospective female mates in the air. And And the similarities to Disney World don't end there. To attract mates, bowerbirds also fill their yards with plastic tat and mass-produced garbage. Marbles, ring pulls, duct tape, bra straps, ribbons, pegs, glass wrappers, and even syringes, always with the largest items toward the back. One bower was found to have bottle caps arranged in an arc around a plastic doll splayed in the center, eyes wide and mouth open in a plastic scream. They also include plenty of natural materials, feathers, stones, shells, leaves, flowers, beetles, body parts, and so on. But interestingly, bowerbirds living close to humans show a preference for our trash because they know its color lasts longer. This, it turns out, is important. The objects selected for display are meticulously color coordinated. Blue is their favorite of the satin bowerbird, while the great bowerbird likes purple, red, and green. Number 6. Sociable weaver apartments. Few birds are so descriptively named as the sociable weaver. These sparrow-sized birds, native to Calaria, weave sprawling communal nests like avian apartment complexes for 100 or so families to live in. Each block resembles a haystack in the tree and follows a typical blueprint. Large twigs are used for the roof, while grasses are woven into the 4 to 6 inch chambers, or apartments, which are then lined with soft furnishings like fluff, cotton, and fur. Entrance tunnels can be as long as 10 inches and lined with spikes of straw to keep predators at bay. Further protection from tree snakes and honey badgers comes from the choice of tree. Smooth, tall trunks or even telephone poles are best. But cheetahs, vultures, owls, and eagles often find their way up to the roof of the complex just to enjoy the view. The birds' droppings enrich the soil, resulting in more leaves for food or shade on the trees. The sociable weaver's sociality even extends to other birds, building more chambers than they'll ever use themselves. They welcome other species to the block. The South African pygmy falcon, for example, depends on their hospitality. Other visitors include the pied barbet, ashy tit, familiar chat, red-headed finch, and rosy-faced lovebird. This benefits the colony as a whole. Not only do the weavers learn new sources of food from these other birds, but they also get more lookouts for danger. When the extra rooms are empty, sociable weavers move between them. In the summer, they'll favor the cool outer rooms, and in the winter, they'll migrate to the center. Fledglings reared and nourished by the whole family, including older siblings, often stay in the nest, relocating to different chambers when it's time to leave their parents. Some weaver nests have even been occupied for more than a century. Of course, the building and upkeep of such a complex requires constant coordination, and the bird's chatter can be heard all around. If it gets too heavy, several tons sometimes, it can break its supporting tree, which really brings to light how much we don't understand about animal intelligence. Number 5. Agglutinated foraminifera tests. If you've heard of agglutinated foraminifera before, give yourself a pat on the back for being able to say it. These single-celled microorganisms live more than 6 miles under the sea. Specifically, they inhabit the Mariana Trench on what's known as the Challenger Deep, which, though it sounds like the name of a submarine, is the deepest surveyed part of the seabed. In fact, it lies in the Hadal Zone, named for the Greek underworld, far beyond the previously thought deepest part of the ocean, the Abyssal Zone. You get the point. It's a deeply inhospitable environment, and there's not a whole lot to build with. Everything down there breaks down into clay, the smallest soil particle, which isn't much use underwater, let alone 12,400 tons per square meter of it. It's no good whatsoever for agglutinated foraminifera, which build their shells out of minerals like calcite, silica, and quartz. In 2010, however, researchers were surprised to find specimens from the Challenger Deep with beautifully formed shells, or tests as they're called, of various minerals, including quartz and calcite. These tests are presumed to be formed or agglutinated from the sunken, decomposed remains of coccoliths, calcium carbonate-plated algae, and phytoplankton from the sea's sunny surface. In other words, they build their homes from what's called marine snow, the matter that sinks down from above, rather like manna from heaven. As for the shells themselves, they come in different designs. Some are spirals, like tiny snails, while others are tubular, with chambers in a row. Number 4. Prairie dog Giga cities. Prairie dogs are squirrels that live on the ground. Instead of burying nuts, they bury themselves. Black-tailed prairie dogs in particular live in sprawling burrows that humans call towns because of their town-like organization and population, many hundreds or more. They also tend to expand into cities, megacities, tens of millions of residents, and even gigacities, hundreds of millions. The largest recorded town, which covered 25,000 square miles, 65,000 square kilometers, roughly 1/10 of Texas, had an estimated 400 million residents. Not only is that millions more than the 20 biggest human cities combined, but it's not far short of the same total area. That's the population and actual one-to-one area of Tokyo, Shanghai, Mexico City, Mumbai, Beijing, New York, and upwards of 14 other world cities living under Texas as prairie dogs. Anyway, once upon a time in the 20th century, humans exterminated 98% of all prairie dogs as pests. They've recovered slightly since then, and their towns are still impressive organizationally. Each has clearly defined entrances with earth markers, listening posts, toilets, sleeping quarters, and nurseries located deepest within. Families live together and greet each other with a nuzzle, while young pups play together near their burrows. Like the ideal human city, prairie dog towns are even multicultural, with snake, owl, and ferret immigrants settling down in surplus tunnels. Number 3. Termite Mega skyscrapers. In Australia's Northwest Territory, much of the dry plain landscape is dominated by the mounds of two termites. One is the compass termite, whose nests can reach heights of more than 10 feet and are built narrower along the north-south axis to avoid too much exposure to the sun. The other is the cathedral termite, whose nests tower above the ground and any passing mammals at heights of 15 feet or more. These are the biggest animal skyscrapers in the world by far. If the millions of termites inhabiting them were our size, the mounds themselves, scaled up proportionally, would be taller than 3 Burj Khalifas, and in some cases, more than 5. Both the compass and cathedral termites' mounds can last for a century, which remarkably could also be the lifespan of their queens. Again, scaling up for humans, this means that both queen and tower might last 7 millennia, despite being formed from just saliva, sand, and dung. Inside, everyone has a purpose. Deep inside are reproductives, the so-called queen and her successors, as well as the king that fertilizes them. Then there are the soldiers, the defenders of the mound. In the case of cathedral termites, these are nasute soldiers, meaning they have a long nose tube specially adapted for squirting sticky saliva at invaders. After them, and most numerous of all, are the workers, whose job is to build and maintain the nest, as well as to feed and tend to the young and reproductives. They rarely leave the darkness of the city. Number 2, ant empires. Sadly, the only way for humans to view the beauty of an ant's nest is to fill it with plaster, hot wax, or molten metal, killing every last one of its occupants. The resulting cast, though it'll cost you your soul, can be excavated and studied in detail. In this way, scientists have found a remarkable degree of planning and consistency in ant nest construction, which is all the more remarkable given they build in the dark without a leader or plan. And ants working on one side have no means of communicating with ants on the other, no means obvious to us relatively unevolved bipedal ape descendants, that is. Really, ants work much like cells in an organism, and these organisms, the colonies, can get pretty big. Nests belonging to the same species in any given area tend to merge together in vast territorial systems, sometimes numbering hundreds of interacting colonies. Nest features typically include food storage chambers, brood chambers for eggs and the young, the queen's chamber at the heart, and waste disposal chambers on the outer edge for the deposit of dead ants and exoskeletons. These are joined by angled, vertical, or even spiraling shafts, which also provide ventilation. The variable depths and sizes of chambers provide the range of microclimates ant colonies need, particularly specialist species like those that farm fungi. They navigate their nests by chemical signage, similar to how they get around outside. And finally, number 1, bee 3D printing. Honeybees are more efficient than we could ever be. Like termites and ants, every bee in the hive has a purpose, but it's for their building work, not their social organization, that they get a place on this list, although the two are related. Darwin thought it the most wonderful of all known instincts, the way bees build their honeycombs with wax from their abdomens. Each consists of geometrically flawless hexagonal cells that fit perfectly into the grid, even while they vary in size to suit either drones or workers. What makes this even more remarkable is that honeycomb is built from different directions simultaneously. Bees starting from different sides of the grid in progress somehow join up with mathematical precision. This isn't robotic behavior though. Studies have shown a high degree of adaptability during construction, with each bee cleverly adjusting its work to attain that geometrical perfection. They might, for example, use heptagons and pentagons where necessary, or alter the orientation of cells. A simple robot does not have such a level of adaptability and rate of error recovery, said entomologist Raghavendra Gadakar. It is, according to the authors of one landmark study, a true architectural skill. Anyway, I hope you found this video to be as entertaining and informative as I did. And if so, go ahead and do all that algorithmic jazz and be sure to follow the links in the comments. I'm Eric Malachite, and I'll see you next time, Space Cowboy.